Now today's our topic is motion in class 9, and now I start average velocity and average speed. Today's our topic is average speed and average velocity. What is average velocity? The average velocity is the arithmetic mean of initial and final velocity. The arithmetic mean of initial and final velocity is defined as a average velocity. If we take initial velocity by u, final velocity by v, then average velocity will be u plus v by 2. There are two velocities, therefore divided by 2. And this is a arithmetic mean of initial and final velocity, where u is represented by initial velocity, v is represented by final velocity, and if we take arithmetic mean of those velocity, then we get the average velocity. As we know, the velocity is a vector quantity. Average velocity is also a vector quantity, and its SI unit is meter per second, because the velocity has unit meter per second. If velocity is unit is meter per second, then their mean is also meter per second. Now the next topic is average speed. What is average speed? The total distance covered by the body to the total time taken by the body is known as a average speed. Or we can say that ratio of total distance by the body to the total time taken by the body is defined as a average speed. Average speed is represented by V average, as average velocity is also represented by V average, and V average is equal to total distance upon total time. V average is equal to total distance upon total time. Its SI unit is also meter per second. Both SI units are same, meter per second, but both formula is different, both different definition is different. But in some numericals, when we do some numericals based on the average velocity and average speed, then if in that numerical there is no initial velocity and final velocity is not given, then you have to take this formula of average speed as a average velocity. But if there is given that the displacement is 0, if net displacement is 0, it means velocity is 0, then average velocity is also 0. Now our next topic is distance time graph. In this chapter you studied about two types of graph, distance time graph and velocity time graph. In distance time graph, we plot graph between distance and time. If the graph is between distance and time, then this graph is known as a distance time graph. For making distance time graph, we draw four diagrams here. I draw four diagrams here. First diagram is this, where distance is along y-axis, time is along x-axis. If the graph is parallel to x-axis, parallel to time axis. If the graph is parallel to time axis, that is AB, then this means this shows that body is at the rest position. This shows that body is at rest position. There is no slope, there is no angle, angle is 0. Slope is always from the, if line is some angle, some incline that line, then there is some angle. But this is parallel to x-axis. When two lines parallel to each other, there is no angle. There is no angle, it means slope is 0, that is v is equal to 0. In this case, there is no velocity of the body. Velocity is at the rest, means there is no change in the position of the body. Now the second graph is also distance time graph. In this case, distance is along y-axis. Distance is always along y-axis or always along vertical, and time is always along horizontal. If the line is straight line and there is some angle, straight line, but there is not parallel to distance and parallel to time, then there is some slope, and this slope is same at this place, at this place, at this place. If we take any at any slope at any point, then this angle is always same. This shows that the body is in uniform speed. There is no change in the speed of the body. If body's speed is 10 km per hour, then it always 10 km per hour, because there is no changes in the direction of this straight line. There is no curved line. Again, the distance time graph for a uniform motion, for a uniform accelerated motion. Now, the graph is in this way. Distance is along y-axis, time is along x-axis. The graph is not a straight line, this is curved portion but increasing direction. This is a curve but increasing direction. This increasing direction represents that velocity is increases with respect to time. Velocity is increases with respect to time. Then this is motion is known as a accelerated motion. This graph represents accelerated motion. Now if the graph is in reverse direction, means the graph is not a straight line but that is increases and then decrease. Curve, this graph is a curve but opposite to the initial diagram. Then this graph shows that body is de-accelerated motion. De-accelerated motion means velocity decreases with respect to time. Initial velocity is more and final velocity will be less. As in the example of brake, when we apply brake in cycle, bike or any other vehicles, then our speed is reduces than the earlier. This graph shows the de-accelerated motion. When we accelerate by taking accelerator, we plot a graph in such a way there is a velocity increases with respect to time or earlier position. Okay students, thank you.